Hello friends, सबको नमस्ते. So today in this video we will use RF-DETR based model. The model here RF means overflow, DE means detection, TR means transformer. It is a real-time object detection model which is made by the Roboflow. I did not explain this model. I just want here in this video I just want to explain you how you can train this model on a custom data set. Okay, you can search it in our Google Google and you can read the data related to this. So here I can explain you how you can upload the Roboflow model in your dataset in your Google Colab. Okay. So this is here over dataset, then download dataset, then this, then continue, then show code, and you have to format will be COCO. Okay, because RF-DETR transformer based model basically use COCO format for the training purpose. Okay, just copy this whole thing and just paste it here. Okay, delete this part because we already used it. So first cell will be download the Roboflow package. Then just run this cell, your data cell will get downloaded. The dataset which we are using is here Pothole. Okay, pothole detection. We train this RFDETR model on a custom dataset which of pothole. Okay, this one. So the dataset is downloaded, and main thing is that you have a three folder: test, train, and valid. And each folder you will get images with this annotation COCO JSON file, which basically have information related to images with their bounding boxes. Okay, you can see this images, and after some images you will get annotation detail of each image. See this. Now how you can read this information, I will explain you now. Suppose I want to display 5 images from this test directory. So first, for reading the COCO JSON COCO JSON file, the information in that, you have to use pycocotools.coco, the import COCO here. Then inside this, make a path of the JSON file. This is a JSON file of that test folder. This is a test folder directory. It will give me the list of number of images in a particular test directory. Now we have to create the annotation, or you can say COCO, where object of that. For that you have just give COCO and just give the path of that. Now we have to now here to get these IDs, how many number of IDs is present that, or you can say number of images. So just use coco.get image ID. All the IDs you will get, number of IDs present in that particular COCO. You can say COCO JSON file. Okay, now here see, I have to just display starting 5 images. So just for image ID in image ID 0 to 5. Now I have to get first I have to get the first I have to get the information of that particular image. For example, starting image, you can say, see, this is the information related to starting image. So how I can retrieve it? Just use coco dot load imgs image. Just give the image ID and 0 index. You will get this information. Okay, now I have to read the image. We want image path. Now to get the image path, we have to use os path join image directory. Now to get the file name, just use image info because the information is stored in this variable. Now image info, then file name, you will get the file name. This way we generate the image path, then we read it. You already know that able to read image in BGR format. So here we have converted it. Now we have to get the, you can say, ID of that. So how we can get it? For the annotation detail, we have to use annotation ID coco get ANN IDs. You will get in image info ID. You will get the ID of that. After getting the ID, to get the annotation detail, You can see it. This is the annotation detail of ID 0. So how? Just coco dot load ns annotation ID. Just pass the annotation ID. All this information for ID 0 is stored in this variable ns. Now let me run this cell and just show you the result of that. See, 68 number of images we have. This is, you can see, first print off is image IDs. So these are the image IDs. Now second is image info, which is like this, which have attribute ID, license, file name, height, width, and data. So this is this one, ID for zero index, zero ID value. Okay. And after that, I have printed annotation ID. So this is annotation ID for 0. Now for to get the annotation detail, I have used load annotation. So this is load annotation detail of first 0 ID. So this is stored in this annotation variable. So this way we retrieve the information from this JSON file. After getting it, bounding box variable basically have bounding box details. So AI for annotation in ANNS, then we get the bounding box detail. Inside the bounding box category ID we will get. After getting the category ID, for getting the class name, we use coco load cat category ID 0 dot name will give me the category ID, or you can say class name. After getting it, we just display the rectangle int x and y, basically the, you can say, top left coordinates of the bounding box. X plus w give me x coordinate of bottom right. Okay. And y plus h give me bottom right by coordinate. So this way we generate x min, y min, x max, and y max coordinate. After getting it, we have to display the text also, and I want to display the text above the bounding box of the top left coordinates. So how I can want to give it? Just give int x, then I have to minus y minus 5. This way I give the information, or you can say put the text above the bounding box. Okay. So this is just display the figures. Now I have to comment all the print options here, and let me run this cell. Anything? Okay. Now let me run this cell. See, pothole. Okay, everything is done. Now to RFDETR package, we have to install that package. Now here, see, I have to import RFDETR-based model. I already tell you that this is a Roboflow detection transformer based model. Here we make the object of that RFDETR. History basically is, you can say, it is a list, or you can say it is an array which store all the information related to each epoch, loss, accuracy, everything. Now to append all the information one by one, after every epoch end. So you have to use this function def callback data. Okay. And history dot append data. We appending the data of every epoch after its end of each epoch. Okay. So here how we can do it? Model dot callback on fit epoch end means it, this function will call after each epoch end dot append, then callback to this function will call, and all the information stored in this history. Now we have to train the model on a custom data set. So just give the directory of that. You can say the directory, then the epoch, batch size 4, because I want when the images will be separated, I want in learning rate will be le minus 1 4. Okay. Or in logarithm you can say 0.00004 means 0.40 then 4. Okay. So let me run it just for the 5 epoch. see here is pre-train weight file. This is the information. Epoch 1 is started. Here 29 is representing as a number of batches. Okay, so it's going on. So this cell is basically here we have converting all the history in the data frame. Then we retrieve the information df.epoch train loss. So it will not get information. I will explain this cell afterward, because when the creating get completed, this history variable get all the information. So it's better I will explain you this whole thing afterward. Now this is drawing bounding box for the test purposes. Okay, so draw boxes, image, box, label, class name. Then we have to first make the image copy. Box variable basically contain coordinates value of top left coordinate and bottom right corner bounding box. I have to extract that. So for that I have used map int, then the box, xmin by min, xs by max, random choice for random color sample, basically the list of all the colors. So here I have randomly choose the color. Then I have to make the bounding box around the pothole. Just keep the image with boxes. Xmin by min, xmax by max. I already told you xmin by min basically the top left coordinates. Xmax by max is the bottom right coordinate. Then the color 2. Then we have to put the text. Then the image with boxes. Then the label. I just want to put the text above the bounding box of the top left coordinates. So just x min y min -5 because I want to display just above, means I want to want some distance between, or distance, or you can say space between the coordinate and the text. So that's why this is a font. This is a one will be the scale, color, 2 is the thickness, then the line, and just written the image. Okay, now here you can see that multiple weight file will get generated. It's taking time. I think the training is going on. Yes. So let me come back and this whole training got completed. So I can explain you this cell also, and in the last cell here where I will tell you how you can upload a pre-trained model which is trained on a custom data set. Okay, so let me complete this training. So the training is completed. You can see it. Okay. So now let me explain you this thing, that why we had converted this history variable to data frame. So first I will print history. You can see that when I print the history is not, we cannot read it. What is this all things? Okay, we cannot read it. So to make it readable, I had converted that particular history into data frame. Now let me print a data frame. Now you can easily read it that for the 5 epoch training learning rate is this one, training loss is this one. Okay, so this way that's why I have converted that particular data frame or you can see the history into the data frame, and it's make it more readable, and you can easily extract the things easily. Now plot.figure 12.12 or 8 is a size. Plot. First we have to plot epochs, df epoch, and train loss. We have to plot the train loss. Label will be training loss. Marker will be 0, and marker 0 here you can see that dot. You can see this marker means this the dot line. We want to display this dot line. We want to mark each point. That's why marker that's this way. Now line style will be dash. You can see this train loss, this training loss, like this one is straight line, but for the dash purpose, dashing line we use 2 dash. Okay, so this way we display the plotation. df epochs here means basically this x axis, you can say, see x axis 0 0 0 1.1. These are the, you can say this is x coordinate, and for the y coordinate this is train loss for the this one, and this test loss for this one. and label will be training loss, validation loss. Marker 0 means we want to mark each point. You are displaying that this solid circle, the solid circle's color with blue and orange, this want to display. Now title will be for now. This is just for the plotation of line, dash and line, train loss and all this. Now for the entire plotation, we use plot.title, plot.xlabel, ylabel, legend, grid. Okay, well, this is so this way we plot the train loss and validation loss, and it's I think pretty good. Train loss is decreasing and validation loss is also decreasing. Now I already explained this cell. Now here we have to now load the model. The model here are multiple models you can say, or multiple weight file you can say. Checkpoint.pth, checkpoint dot checkpoint best EMA best regular total. The model which we are which the model which we not model the weight file which we use is checkpoint best total. Okay. So just keep the path of that. You will upload that weight file. Then this is state directory. These are the color samples for displaying multiple you can say bounding boxes with different color. The class names which we have is 0 for the background and 1 for the pothole. First, we have to make the list of all the file name present in that particular directory. Now, I have to plot 16 images. So, for the plotation of the 16 images, there will be 4 rows, 4 columns. Each figure size will be 16 by 16. Figure is basically representing the entire figure here. Here, X is here in this line. X is in a 2D format. When I will use X.table, it's converted me to 1D format, and I converted just for the ease of iteration. Okay. Now, IDX in range of 16. IDX in range 16 means I want to plot 16 images, so that's why I loop it 16 times. So this is random choice. First I will randomly select the file name, or you can say the image file name. Then I have to create the image path. Just for creating the image path, os path.join the text image directory, then image path, image name. Now I have to read the image path. We do not want to print the image path. Then just keep the model in model.predict. Just keep the image. Okay. Now in this you can see, let me just for the how we are extracting the information. Let me run this for just one iteration. See, x by array means x by is a bounding box detail. Okay. Or here see class id other data. We want x by and the confidence and the class id. Class id is this and this confidence is this one. So this way we extracting the information, and why we are looping it, why we are using for loop over this all thing, because it might be possible in one image multiple bounding boxes, multiple pothole will be present or multiple bounding boxes present. That's why we looping over it. So this way retrieve information, or we can say extract the information. Predict x by give me the bounding box detail. Prediction dot confidence give me score. Prediction dot class id give me the class id. Okay, now here just for getting the label, just use class name that pass the id, you will get the label. Now just pass the image. Means we want to draw the bounding box, so use draw boxes, which I have explained you above in the code. Just pass the image, then the bounding box, then the label, then the color sample. Then just show the image with access off, title layout, and plot the image. Now let me run this cell. See the model. I think draw boxes is not defined. I think no, I have not run this cell. Sorry. It's done. Okay. Now run it. Fill image or ND get. Oh, I think so. I am reading the image with image path. So where is the line problem? Let me solve this problem. So the problem is solved, and the error is occur because because we have randomly select the image file name, and it might be possible that it randomly selected this JSON file. Okay, so that's why it throw the error. Now let me run it again. It will does not throw any error. Okay. See the result. This is a RF-DETR based model. Okay, and its model is trained on just 5 epoch, and it's showing a great result. Okay, so this will be trained RFDR based model on a custom data set, and you can use it. And after training it, you can use that particular weight file anywhere you want. So this is just an explanation how I. Okay, just please like, share, and subscribe. Thanks to all.